Alright, so we are going to practice a write in, write out FRQ. And so one thing to keep in mind about these FRQs is that they are usually calculator allowed. So just a reminder, there's 2 calculator FRQs and there's going to be 4 non-calculator FRQs. Right? 2 of your 6 FRQs will have real life context, and the write in, write out one is usually one of those that has real life context. Alright, and then a calculator tip is that you can put Y1 as your write in, and then Y2 as your write out, and then Y3 is going to be Y1 minus Y2, and that is going to be the rate at which whatever it is changing, and we'll talk about one with fish in just a second. Alright, and then a lot of times that you have to interpret your answer, and you need to make sure you use units and context whenever you do an interpretation. And I highly recommend that you quote the words of the problem. Okay, and so for our notes, we're going to do number 1 from 2019. So I'll pull it up here. Okay, so this is number 1 from 2019. It says that fish enter a lake at a rate modeled by the function e, given e of t is 20 plus 15 sine of pi t over 6, and fish leave the lake at a rate modeled by function L, which is L equals 4 plus 2 to the 0.1 t squared. And both E and L are measured in fish per hour, and T is measured in hours since midnight. Right? So what I would do as soon as I got to this question, I would go to the calculator and I would type in E of t in for Y1, L of t in for Y2, and then I would make Y3 be Y1 minus Y2. Alright, pause the calculator, or pause the video if you need to, but part A says how many fish enter the lake over the 5-year period from midnight, which is when t is 0, to 5 a.m., which is when t is 5, and give your answer to the nearest whole number. Alright, and so we have that fish enter this. This is a rate at which they enter, and we want to know how many fish. And so that we're going to be accumulating fish. And so we would go to our booklet. Now remember, on the real test you won't be able to write anything. You won't be given a page with the problem. It'll be on the computer. So everything you write, you would want to write it in the booklet. Alright, and so we're accumulating fish for 5 hours. We're going to do an integral from 0 to 5. And then do not write out the equation for E of t. Just write it in symbol form. Just write E of t. It takes too long to write all that out. They know what E of t is. And then you do need to write that down so you're telling the people like what you're finding. But then we can find that integral in the calculator by doing alpha window, choosing number 4, and going from 0 to 5. And then remember that we did entering for Y1. Alright, and then it does tell us to give the answer to the nearest fish. So that would be 153. And then I'm going to just write a little sentence that gives the answer. And so the original question, let me look at it real quick. The original question is how many fish enter the lake? And so we are just going to make sure we answer that question. So 153 fish enter the lake from midnight to 5 a.m. All right. All right, and then for part B, we want to know what is the average number of fish that leave the lake per hour over the 5-hour period from from midnight to 5 a.m. All right, so when we're looking for an average number, like we just learned this recently, we're looking for an average number. That's when you're going to do 1 over, and then we're going from 0 to 5, so it would be 1 over 5 minus 0 times the integral from 0 to 5. And this one was about how the average number that are leaving. So the leaving formula is L of t. All right, so you do have to tell them what you're doing. If you don't tell them that, you do not get credit. So we're going to now type in that integral. Don't forget about your 1/5. And then leaving was in y2. Now this one, since we're finding an average, then it's okay that we have a partial fish. So let's make sure we answer the question. And so we would say the average number of fish that leave per hour in that 5-hour period is, and then it'll be whatever decimal that we got. Now, I know I probably don't have to tell you, but on this one we do need to make sure we're accurate to 3 decimal places, so we would either round or truncate, which is going to give us the same value. All right, so let's look at C. C says at what time, T, from 0 to 8 is the greatest number of fish in the lake, and we're going to justify the answer. So we're looking for a maximum. Now there are actually 2 different ways to do this problem, and I'm going to show you both ways. One way is definitely easier, but I want you to see both ways because it's possible that on your problem you're going to need to do the candidates test. So I'm going to, like I said, I'm going to show you both ways. So we're wanting, we're combining entering and leaving, and so let me look at it again one more time, sorry. We want to know when the greatest number of fish are in the lake. And so what we need to know and make a note of for the people reading our exam is that E of t minus L of t represents the rate of change in the number of fish in the lake at time t. And what we want to know is when that number of fish is the maximum, is the largest. And so we need to remember that maximums occur when the rate of change or when the slope is 0. And so what we need to do is figure out when E of t minus L of t equals 0. And we have to tell them that. We can't just find it and keep it to ourselves. We have to tell them when that is. So we're going to go to y equals. Now I'm going to turn off y1 and y2 because if we get too many graphs on here, it's going to look kind of crazy. And I think I've already changed my window. Yes, so we only care about from 0 to 8. So there it is. All right, so we can see that this rate of change in the number of fish is 0 at this point right here. And so we would want to calculate it. We can't just estimate, we actually need to calculate the 0. So you have two options, and I think I chose the more difficult option because right now my little cursor is not even on the screen. We're going to move closer. All right, there it is. We're going to hit enter on the left, and then hit enter on the right, and then enter one more time. So that is equal to 0 when t equals, and then I'm going to go to several decimal places. Now, a quicker way to do that, which I would probably do, but I have so many equations right here, you can just make y4 be 0, and then we want to find the intersection. And so we just hit enter on the first curve, enter on the second curve, and then enter again. So it's a little easier to do it that way. So you can either calculate a 0 or make y4 0 and calculate the intersection. Okay, so when that rate of change is 0, that's where a maximum is or a minimum is going to occur. So I'm going to separate this into two parts. So the easier way to give this answer is to look at the graph and see it is 0 there, and the rate of change is changing from positive to negative there. And when the rate of change changes from positive to negative, then it creates a maximum. So we're going to kind of write that out in a little bit more specific words. And so E of t minus L of t changes from positive to negative at t equals 6.20. You can say 3 or 4, it doesn't matter, creating a relative maximum. Then E of t minus L of t continues to be negative. All right, and so there's a maximum there, but then that is going to continue to be negative past or through where t is 8. Therefore, the greatest number of fish occurs at t equals 6.024. Oh, 6.204. I'm going to add that. We're going to say continues to be negative through t equals 8. All right, So that has a lot of words to it. And you have to be really careful. You can't just say there's a maximum there, because there could be a maximum and then a minimum and then back another maximum. So you have to be really careful. I think you actually probably have a better chance of getting it right if you do the candidates test. And so you could do it that way, or you could do the candidates test. And to keep from having to write this number over and over and over again, I'm going to let B equal 6.20356. Now you can have any variable be that. I wouldn't have don't have T equal that, but you could use any variable. I just decided to do B. All right, and then I'm going to make a candidates chart. And so my candidates are going to be either the endpoints, so that's 0 and 8, or where the rate of change is 0, which is at B. So that's 6.2035. And then I'm going to go ahead, while I have my calculator here, I'm going to go ahead and store that. So just hit the store button, and then I'm just going to use B. All right, so now in a second, when I need that, I'll have it stored in my calculator. All right, and then in the second column, we're finding the maximum number of fish, so it is going to be the number of fish. Okay, so I have the rate at which the number of fish is changing. And so if I want to find the number of fish, I'm going to do the integral. Now this first one is kind of weird. The integral is going to be from 0 to 0 of E of t minus L of t dt. And that obviously is going to be 0, so we start off with 0. All right, and then I'm going to have the integral from 0 to b of E of t minus L of t dt. All right, so let's see what that is. And then I know that E of t minus L of t is in y3. Do the integral from 0 to 8 of E of t minus L of t dt. So I'm just gonna change my B to an 8. It kind of already looks like an 8. So also make sure you answer the question. It's really easy to give 135. That's going to be the maximum number of fish. At that time. So fish entering, fish leaving, the maximum number of fish. Sorry, I got distracted. And so you do have to give a justification, and so that the candidates is the work for it, but you would say something like, therefore, by the candidates test, the greatest number fish occurs at t equals 6.204. So same thing, same statement we had the last one. So anyway, I would prefer that you use the candidates test on that situation, because it's really hard to get all the words right. without it. Okay, and then the very last question. Is the rate of change in the number of fish increasing or decreasing at 5 a.m.? Okay, and so remember, the number of fish is from the E of t minus L of t. And so if we want to find the rate at which that is changing, that's a derivative. And so we would want E prime of 5 minus L prime of 5. And our calculator can do that for us. And so we would do alpha window and then choose number 3. And then that E of t minus L of t again is in Y3. And then the number that we're plugging in is 5. Alright, and so you do need to tell what that is, and you want to be accurate to 3 decimal places. And then you need to explain it. Let me look at it one more time. Yeah, the rate of change in the number of fish. Is it increasing or decreasing? So, because the rate of change in the number of fish is negative, then the number of fish, or the rate of change in the number of fish is decreasing. All right, so let's just write that out. So because E prime of 5 minus L prime of 5 is negative, and then I'm just going to quote the problem. We would say the rate of change in number of fish in the lake is decreasing. At time t equals 5.